This is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Today in this session, we are going to see about the ignition temperature and the explosive temperature. First, we will discuss about these in the context of the design thinking pattern. Let us explore how the design thinking approach can be applied to understand the ignition temperature and the explosive temperature within an industry context. So the contents will be we will see about the design thinking approach followed by introduction to ignition temperature, spontaneous ignition temperature, and explosive range of limits of inflammability. The first approach of the design thinking is empathize. So the empathize is nothing but you have to understand the stakeholders, engage with the engineers, safety experts, and operators in the petrochemical industry. In addition to that, we have to conduct interviews and observations to empathize with the challenges related to ignition temperature and explosions risk. The next is the define. So, identify the key factor. We have to clearly define the problem. How can we enhance the safety measures related to ignition temperature and explosive risk? And we also have to consider the key factors like the surface temperature, material properties, and operational conditions, which play a crucial role. Next is ideate. So we have to come with the solution using the brainstorm process. We can also use the smart sensor, develop temperature sensors that monitor the surface temperature in real time, predictive models like create algorithms that predict ignition risks based on the temperature fluctuations. Training programs can be given for the personal handling of the flammable material with care. Prototype. So we have to build a smart sensor prototype, develop a compact, robust sensor that can withstand harsh environment. We can also use the software interface, and also you can develop a training module, that is create interactive e-learning modules and also explain the case studies. So the test, we have to gather the feedback, install sensors in petrochemical plants and assess their accuracy, conduct pilot training sessions and evaluate effectiveness. And next comes the implementation. The roll out the solution, deploy smart sensor across critical areas, integrate predictive models into safety protocols, conduct regular safety trainings. So the thing in the design thinking, the important one is to iterate. So it is a continuous process. DT encourages in the iteration process, so that by doing the iteration process, you can come with a refined and a better solution. Now let's see what is an ignition temperature in the science context. So ignition temperature is defined as the lowest temperature to which the fuel must be heated so that it starts burning smoothly. Ignition temperature of coal is about 300 degrees centigrade. In the case of liquid fuels, the ignition temperature is called the flash point, which ranges from 200 to 450 degrees centigrade. For gaseous fuels, the ignition temperature is in the order of 800 degrees centigrade. Now let's see what is spontaneous ignition temperature. Spontaneous ignition temperature is defined as the minimum temperature at which the fuel catches fire, that is, it ignites spontaneously without external heating. If the ignition temperature of a fuel is low, it can catch fire very quickly. On the other hand, if the ignition temperature is high, it is difficult to ignite a fuel. If the heat evolved in a system is unable to escape, temperature of the system goes on increasing, and when the spontaneous ignition temperature is reached, the system burns on its own. Explosive range or limits of inflammability. All gaseous fuels have two limits called the upper limit and the lower limit. These limits represent the percentage by volume of fuel present in fuel-air mixture. Lower limit represents the smallest proportion of the combustible gas. Upper limit represents the largest proportion of the combustible gas. The range covered by these limits is termed as explosive range of the fuels. For continuous burning, the amount of the fuel present in the fuel-air mixture should not go below the lower limit or above the upper limit. The explosive range of petrol is 2 to 4.5. This means that when the concentration of petrol vapor in the petrol air mixture is between 2 and 4.5 by volume, the mixture will burn on ignition. When the concentration of the petrol vapor in the petrol air mixture is below 2%, that is lower limit, or above 4.5%, upper limit by volume, the mixture will not burn on ignition. Some of the limits of inflammability are given in the table. So we are going to see about the hydrogen, acetylene and natural gas. Hydrogen has a lower limit of inflammability as 4 and the upper limit of inflammability 74. Acetylene 3, upper 80, natural gas lower 5 and the upper 14. Thus explosive range or explosive limit is the limiting composition of the gas-air mixture beyond which the mixture will not ignite and continue to burn is called the explosive range or explosive limit. Thank you.